Hello, this is the first in a bunch of videos which are going to have a look at paper 2 from the October exam from last year. And I'm just going to go show you the calculator approach to the questions that we covered in paper 2. I know that's not everything because we didn't do question 1, for example. If I can, I'll go back and do that. But I thought if I at least focus on the questions that you did answer and show you how to use your GDC might be at least a start, I suppose. So here we go. Few starting comments. Number 1, just because it's in the calculator section does not mean that every single question or part of the question requires or is even better where if for calculator is used. What you need to look for very carefully is what the question is asking of you, and therefore what information do you need to supply? What do you need to show calculations for, and what can you, in inverted commas, get away with not showing? In the case of question 2, here we got A, sketch the graph. Now, there's nothing here that says that you have to show working out. It's worth 3 marks, which is awesome. So you can have a bit of a guess what they want to see. They'll probably want to see some critical points, and they will want to make sure you got the shape right. I'll show you the mark scheme as well, so you can see that. And you can see here, you've got the function here. It's nothing that you should know how to graph really, and that's because you really should be graphing it. So I'm going to go to the GDC here, and you'll be amazed at how many questions, by the way, even if they're not graphical questions, can be really useful if you've got the graph organized. So I've added a graph page, and I've gone to define it. So it's 3x minus 4 to the power of 0.15x squared. Oh, geez. So there's the graph there. Press return, and there's what it looks like. Now, do be mindful of this, that in the paper 2 section, there will absolutely be graphs that you have never seen before. And the reason why they can ask you questions about it is because, well, quite frankly, you've got a calculator that can do the graphing for you. So here's the graph, and you simply need to work out the critical points probably. Just this sketch. It says from 0 to 3, so make sure that you understand where 0 and 3 is. So what have we got? 0, 1, 2, 3. So there's a point in there somewhere. You can use menu trace, and you can say graph trace, and it gives you a little arrow here. It normally starts to trace at the y-intercept, so 0, -1, and then you can sort of click through until you get to 3. There you go, 3, 2.5. So you would draw the graph up to 3, 2.5, and you would put in the x-intercept here. Now, to get the x-intercept, we're going to go Menu, Analyze Graph 0. So remember, another word for x-intercept is a 0. Click to the left, click to the right. There we go, 0.342. Looking at a domain here, it's between 0 and 3, so that's definitely in. So you've got that one, and then you've got to about there, 3, 2.5, whatever it is. Okay, that's basically it. Let's have a look at the mark scheme very briefly. And, oh, sorry, it says from 0 to, I think it was from 1 to 3. It's from 0 to 3. So as you can see here, if you've drawn the sketch from 0 all the way up to 3, which is 2 point something, then that's where you get your 3 marks from. So you're literally copying that graph down, copy, or drawing it in. You've got, this doesn't even have the x-intercept in, but I would have put it in. And you've got the endpoints. So it says award 1 for a smooth concave down curve. That's that, with generally correct shape. If the first mark is awarded, award A1 for local maximum, which is approximately then. Note the point isn't given, it's just approximately the right spot. And the x-intercept in approximately the right spot as well. Award A1 for endpoints at x equals 0 and x equals 3 with approximately correct coordinates. So even though the graph that we draw is the whole graph for x between negative infinity and infinity, we just, critically, if the domain is 0 to 3, then that's the only part of the graph we should draw. And you can use this to approximate. If you want to get a little bit more detail, you can go window zoom, you can go to window setting, and you can say, okay, well, I'm just going to go from -1 to say 4, and I'm going to go from -2 to what looks like it goes up to 4. So I'll go to 5. So do that, and you get a much nicer look to your graph. Then, it's almost identical to that now, isn't it? But you can start seeing the divisions there as well. You can even go menu, window, zoom, window settings, and say the scale. I can never get this right though. So if I get this right, the scale is every 1 unit, and the Y scale is every 1 unit. I think that's how you do it. Yeah, 1, 2, 3, 4, 5. 1, 2, 3, 4. So you've got a much, clearer sense of where all these points are. Okay, so summary for this bit here is use your graph to draw it, copy it in, make sure you get the domain right. And in order to frame your graph properly, do make sure you get used to using the window zoom section and go to window settings. And in order to work out the critical points, make sure you're familiar with analyze graph. Okay, that's that done. Part B, find the value of x for which f dash of x equals 0. Now, you could be forgiven for thinking that you need to find the derivative of that and then set it equal to 0. But this is a bit of an alarm bell here, because we actually don't have a rule for working out a derivative if the base is anything other than e. So what do we do? And the answer is don't find the derivative, because we don't know how to do that. So instead we use derivative properties. We've got a graph, f dash of x equal to 0. So what we're really interested in is working out the turning point, right? Either inflection or turning point is when the gradient of the graph is stationary, which means that f dash of x is equal to 0. So we go have a look at this and we go, well, there's the turning point there. Under menu, if we go to analyze graph, you will see that maximum is one of the things it will evaluate for you. Go to the left of the turning point, go to the right of the turning point, and then let go, and there is your turning point, 2.33, 3.9. For what value of x is f dash of x equal to 0? At 2.33. And we should see that in the solution. 2.33084 dot 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 x equals 2.33 for 3 significant figures. Remember, you have to write it exactly, or you have to write it in 3 significant figures, or according to what the instructions are. So that is question 2 done. I'll leave the video here, and you can return to or go to the next video if you want to see how to do question 3.